Alrighty, hello everybody. So welcome to OpenGL Oversimplified. This is a series where I really zero in on OpenGL features and try to iron out some of the difficult points of understanding that some beginners have. And what I want to talk today about is blending, basically alpha blending. So when we go and draw an object, we're drawing an object on the screen. Think about it like that. And there may already be stuff on the screen. So the way that we want to achieve transparency, if that's our goal, is with something called the alpha value. We have our color channels, RGB and alpha. But by default, OpenGL ignores that. It's sort of, the funny thing about OpenGL is it sort of treats alpha as an arbitrary float with information, and we can do with it what we want. So by default, nothing happens. When we say draw this thing with 0.5 alpha, literally nothing happens. What we need to do is enable that. And I'll just actually set up my environment here. So I'll open up something like that. We'll see how that goes. So just remember that we want to go GL enable, and then there's a whole bunch of things that we can enable, depth testing, all sorts of things. In this case, we want to enable blending, and that's done with the GL blend code. So that's pretty important. But then if we enable blending, still nothing happens because we need to specify the blend operation. So concepts which are super important is the pixel, which is on the screen already, is called the destination. So I'll go destination pixel is on screen. And then we have a source pixel, and that is what we are drawing. So that source pixel is the thing which is going to come and overwrite what's already on the screen. Now, this comes down to something called a combination. So let's say that we have a vec, I'll go vec4 as our result. And what we want to do is we want to take the destination and somehow combine that with the source. So actually I'm going to change this. Let's say we want to make a transformation where the goal is to find what should be on the screen after drawing. The info we have available to us is what's already on the screen and the thing that's coming in. So what I'm doing here, you can see, is I'm just adding this up. But just adding things is not super flexible, and so what we can do is something called a combination. And a combination is putting coefficients in front of these, like multipliers. And then our choice of coefficient affects the sort of effect that we get. And this is the basic idea. So we go over, there's one more thing that we need to set, and that is the GL blend function. So you can see that we've got this GL blend function, and we are setting two things. And these two things are actually the factors here in that combination. So we've sort of got like GL blend func, and then we need to specify the source factor, which, as we can see here, is that factor B in that expression, and then we need to specify the destination factor, which is A in the expression above. So there are sort of three that I'm going to talk through. There's the regular transparency operation. There's additive blending, and there's multiplicative blending. Okay, so for transparency, we want the destination to be a combination where the factors of that combination are determined by the alpha. And specifically, determined by the alpha of the incoming pixel. So if I have a pixel coming in with 90% transparency versus a pixel coming in with 20% transparency, that's going to affect the blend. So I definitely want to add, I'll go, so source alpha will be the alpha of the pixel that's coming in. I definitely want to multiply that with the source. So if I've got a pixel coming in with 10% transparency, we'll say 10% alpha, make it a little clearer, then I only want to contribute 10% of that incoming pixel. That's why I'm multiplying there. If I'm coming in with 80% transparency, 80% alpha, I want it to be mostly opaque. So I want to take 80% of the source pixel. And then for the remainder, if I have 80%, the remainder is going to be 1 minus the source alpha times what's already there. So really important to, or not really important, but interesting to note that both of these factors, if I sum them together, they sum to 1. And you can think of that as that is not fundamentally changing the brightness of the result, if that makes sense. And as we can see here on the left, we have all of these options, and choosing these, so we have GL blend function. So my source factor is going to be, I think it's GL source alpha, and then for my destination factor it'll be GL1 minus source alpha. And this is sort of given in a lot of tutorials, in a lot of basic implementations, but I think it's really good to understand deeply where that comes from, because it then helps us to expand it, right? So if we were to do something like additive blending, okay, so additive blending I actually did before. I said, okay, our destination color will be our source color plus the existing color. So actually this is like 1 times the source plus 1 times the destination. So if I want to achieve additive blend, what I can do is I can go GL blend function and just put in GL1 for each of these. Just like that. The next one is multiplicative blending. So if I've got a shape that I've drawn and then I draw another shape on top, I may want to multiply those colors together so objects can tint each other. And the way I would do that is, the idea is I want my destination to be my source color times my destination color. So then the question is, how do we work that into the framework of this GL blend function? Well, it turns out that just like GL source alpha or destination alpha is a real code that we have applicable to us, we can also see that source color is available as well. And so a way that I can achieve this is I can go GL blend function, and then for my source factor, I'll go GL destination color. So what this will do is it will take the incoming color, multiply it with the existing, it'll multiply the 2 colors together. And then what I want to do, this is a bit of a hack, but I then want to add 0 because I've already done my blending in that first term of the combination. So another way to look at this is destination color times source plus destination color times 0. That does what I need it to do. Okay, now, so far all of this has been to do with I'll circle back to that. But note here that with transparency, we can see that the order matters, because transparency is not some magical operation that remembers everything in the order that it was drawn. It's just done like a simple one-step transformation. There are a few options, a few basic options. The most basic option that I can see, if I have a series of objects and I want to apply transparency to them properly, I will need to sort them by depth, sort them by distance to the camera, so that the furthest ones get drawn first, and that's always making sure that doing a one-step transformation all along the way, I'm capturing all of the info which is in there. But if I'm not doing a series of transformations, like let's say that I've got a series of tree sprites or something, and I can see the branch and I can see the leaves in that, but all the other info inside that image is completely transparent. So I'm never going to be properly blending it. I just want to be able to see past the trunk or something. So what we can do as well is there's a discard keyword, and this is how it works. Inside my shader, I can do some sort of test, like float alpha equals some stuff. Usually I'll sample from the texture. Let me go through the full thing. So I'll sample from the texture. So I'll say vec4 sampled. I'll go texture. Something like that. And then I can extract the alpha just with the alpha component, just like that, no problem. And then I can do some sort of test, like if alpha is less than some threshold, choose this as you want. Then I can just go discard. And what that will do when we run that inside a fragment shader is, for any pixel which is suitably transparent, it will just not draw it. And that has the advantage that I can then draw a bunch of sprites out of order, in random order, and it's really decreasing the chance that graphical glitches are going to be in there, because it's literally not executing the fragment shader. It's just stopping early exit. And that's very popular, and I use that a bit in my own projects. Now I'll circle back to that other thing I was going to talk about, which is, so far I've been talking about vec4s, which is the RGB and the alpha. But there might be situations where I actually want to have separate control over my color and my alpha blending. And that can be achieved with GL Blend Func Separate. So what GL Blend Func Separate does is it does a combination for the color and a combination for the alpha, and it lets us specify different factors for each of those two combinations. It's pretty surprising how flexible you can be with that small set of functionality. So I will leave it to you to think through this, understand it deeply, maybe incorporate it into your own projects. But yeah, that's been this session of OpenGL Oversimplified. See ya. Hi everybody. Look, I just want to say thank you to all of my channel supporters. I know I'm out here in the wilderness. It really does help, even if it's just the motivation to keep making videos. That means a lot. It's $2.50 a month. That's it. If you can't afford to support the channel, totally fine, it's not expected. The best thing you can do to support the channel, if it's not monetary, is to comment. Let me know what sort of content you'd like to see, and let me know if there's anything that I can improve, because I am trying to work on that constantly. So, supporters, I have a list. This is how I plan my life, with lists. Step 1, get my life back on track. Step 2, big question mark. So, channel supporters, thank you Antonin Carret, Dankyo Foles, Declan, Endelon Studios, Isaiah Meyer, Jason Coleman, Matthew Derick, Moim, Sheriar, am I saying that right? Sorry, and Skibbity Pop. Thank you so much, my dudes. Means a lot. Thank you. Bye.